Hello, future engineers. Welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends, to your younger brothers and sisters who would want to take up engineering in the future, and to your relatives. That's one way you can keep me going, inspired, and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. Hello, future engineers, subscribers, viewers, and students. Here are problems in algebra, particularly in coordinates and graphs, continuation. And here we are going to define slopes and directed line segments. And I hope that from here, your knowledge on computing slopes will increase. If you want to anticipate the solution to these problems, you may do so by pausing the video. So directed distance and slope. So if we have a line segment directed from point P1 to P2 with corresponding coordinates shown, then it should be, for the directed distance, it should be terminal coordinate minus initial coordinate. So if it is P1, P2, then the terminal point is P2, so this horizontal distance is x2 minus x1. And it is positive because from 1 to 2 it is rightward in the positive direction. It is also positive in the upward direction. So the vertical distance would be y2 minus y1. So I'll call that theta, so that from the figure tangent theta is quantity y2 minus y1 over x2 minus x1. That's the slope. And I will discuss the possible signs of the slopes and in which quadrant must the line segment falls in order to have positive and negative slopes. So slope, which is the tangent that the line segment makes with the positive x-axis, positive in the counterclockwise direction, is opposite y sub 2 minus y1 over x2 minus x1. And the directed distance 1 to x is again the 2 here. The second point is the terminal point. The first point, the leftmost point, is the initial point. So it should be terminal coordinate minus initial coordinate. So in this case, for the horizontal distance, right line segment, it is x sub 2, the x coordinate of point 2 minus the x coordinate of point 1. And this is positive because point 2 is rightward of B1. And you just evaluate that value. Then distance, that's the midpoint. Distance 2 and x is x1 minus x2 because this is from 2 to 1 and point 1 is to the left of P2, and of course this direction is leftward, and of course x coordinate of 1, the terminal point, is x1 minus x coordinate of point 2, which is x2, and this is expected negative. And another reason is point 1 is left of P2. Then distance 1 to y, 1 to y, which is this, because the direction from 1 to 2 along y is upward, it is expected positive. And based on our definition, 2 is the terminal point, so that's why you have y sub 2, then minus initial point 1 minus y coordinate of point 1, y1. It is positive because another reason is point 2 is above p1, while distance 2, 1y, the y component of directed distance, is 1 is the terminal point, 2 is the initial point. So from 2 to 1, it's in the negative direction, downward direction. And it is y coordinate of the terminal point, which is y1, and minus y coordinate of the initial point, which is 2 in this case. So y1 minus y2 is expected negative, and another reason is p1 is below p2. So the slope, which is the tangent of the angle theta, would be positive if the angle is between, so remember the reference is the positive x-axis. So the slope is positive if this is the line segment direction. So if it is positive from 0 degree to 90 degrees, so all tangent function value, tangent of angles between 0 to 90 degrees would be positive. And that's the reason why, because this is the position of the line segment and that's the angle in counterclockwise direction. It is also positive between 180 degrees, this line here, up to up to 270 degrees. So the slope is positive if it falls in the first quadrant, 0 to 90 degrees, and 180 degrees to 270 degrees in the third quadrant. So tangent of angles between quantity 180 to 270 would be really positive. Then the slope is 0 when the line coincides with the positive x-axis or the negative x-axis. And on the positive x-axis, the angle there is 0 degree, and on the negative x-axis, that's 180 degrees. So I hope it's clear. Then the slope is negative if the angle theta from the positive x-axis is in this direction, is in the second quadrant or fourth quadrant, and the slope is 0 as negative because tangent of angles between 90 degrees here to 180 degrees are negative. The tangents are negative, so that's why the slope is negative, or the slopes are negative for that range of angles 90 to 180 degrees. Also from 0 to negative 90 degrees, or the other term is 270 degrees to 360 degrees, the slopes would be negative. Then when the line is vertical, of course, it is the slope is undefined or meaningless. So that's it. That's the summary for determining the signs of the slope of the line segment. So let's have this problem. Compute the slope and the angle that the line segment makes with the positive x-axis. If the initial point is the origin and the terminal point of the ray is the point P with the coordinates given. So these are the terminal point of the ray, and the initial point is the origin. Therefore, the slope is simply, if we denote this as uh, x2 and or xp and yp, these points here, xp and yp, then the slope will just be yp minus initial point, which is the origin 0, over xp minus 0. So in short, the slope reduces to simply yp over xp. So the ratio of the ordinate y and x. So it reduces to this case. So that's why the slope of line A is 5 over 3. So 5 over 3, and theta c is inverse tangent of 5 over 3, so it is 59.04 degrees counterclockwise from the positive x-axis. So the requirement here is slope and angle that the line segment makes with the positive x-axis and in the standard manner. Then MB is 6 over negative 2. 6 over negative 2 is negative 3. So the slope for the line segment from the origin to this point is negative 3. And this is in the second quadrant. Therefore, the angle is, if you use your calculator, arc inverse tangent of negative 3 is negative 71.565, but because it is in the second quadrant, then it should be added to 180 or 180 degrees minus 75.565 is 108.45 degrees in standard position. The other way is in clockwise manner, it is negative 180, then plus negative 71.565, negative 251.565 degrees. So in clockwise direction from the positive x-axis, that line from the origin to this terminal point makes an angle of negative 251.565 degrees, or in standard position positive angle 108.45 degrees. For C, it is negative 3, slope is negative 3 over negative 4, and it reduces to 5/4. So use your calculator there. Then inverse tangent, but because these are all negative, the angle falls in the third quadrant. By the way, for part B, if you're confused, so this is this is line B, and if you use your calculator, it will give you negative angle. So therefore, that's this angle here. That's negative 71.565, but it is directed from the origin to that point. So this should be the angle, not this angle here. So that's why the angle is 180 degrees minus the angle, absolute value of the angle calculated. So 108.45 degrees, and in negative direction, in clockwise direction, negative 251.565 degrees. Then at C, negative 3 over negative 2.4, it is in the third quadrant. Then if you use your calculator, inverse tangent of 5 over 4, it will give us an acute angle, which is the angle it makes with the x-axis. Then all you have to do, in standard position, that's 180 degrees plus the angle calculated, arctan of 5 over 4, and that's 51.34, definitely 51.34 degrees. So that's why 180 degrees plus 51.34 degrees is 231.34 degrees. In clockwise manner, it is 231.34 degrees minus 360 degrees. 231.34 degrees minus 360 degrees will give us negative 108.66 degrees if measured in clockwise direction. MD is negative 3.6 over 1.5, so it's negative 12 over 5 if reduced and expressed in fraction. And it falls in the fourth quadrant, therefore the angle is, if you use your calculator, automatic inverse tangent of negative 12 over 5 is negative 67.38 degrees, but the meaning of that, it is in clockwise direction. In counterclockwise direction, which is positive, then add 360. 360 plus negative 67.38 degrees is 292.62 degrees. Then it is shown here also. This is the point 1.5 gamma negative 3.6, and this angle is equal to negative 67.38 degrees. Then if you don't mind, if you just make it absolute value, it is positive 67.38 degrees, but this is the actual angle. Then if expressed in positive way, counterclockwise direction, it is 360 degrees minus 67.38 degrees. So that's why you get 292.62 degrees. Then E, negative square root of 3, 4, which is in the second quadrant again. Then this is 4 units. This is square root of 3 units, but just made positive so that we can compute this angle directly. Inverse tangent of 4 over square root of 3 is 66.59 degrees. Use your calculator there. But from the positive x-axis, it is 180 degrees, this angle here, 180 degrees minus 66.59 degrees, 113.41 degrees, but the calculation is no longer shown in detail because if you watch the video and listen to the explanations, you can follow, of course. In negative direction, it is 113.41 degrees minus 360 degrees, so negative 246.59 degrees. F, it is 0 over negative 3.2, so 0, but this point is in the in or on the negative x-axis, so it's here. So the angle in that direction from the positive x-axis is 180 degrees, but it will give a 0 if you just rely your calculator. So 0 slope, inverse tangent of 0, definitely your calculator will give you 0, which is not because it should be 180 degrees. The point lies here, somewhere here. So it is 180 degrees. Negative 3.2 is here. So negative 180 degrees, or in clockwise direction, negative 180 degrees. Then at G, we have definitely 0 comma negative pi over 2. So mg is negative pi over 2, which lies somewhere here, somewhere here. So origin to that point, vertical line on the negative y-axis. So that's why the slope is meaningless or undefined, and specifically because the point lies here, in standard way, it is positive 270 degrees, in clockwise direction, negative 90 degrees. Problem 14. Given the points A and B, find the directed distances AB, BA, and these are the coordinates of A and B. We have three cases here. So let's locate negative 1 comma 7, which is here, and B6 comma 7, which is there. So direction A to B is to the right, so expect that directed distance AB is positive, while directed distance BA would be negative. And it is AB, so 6 minus negative 1. Of course, 7 minus 7 is 0. That's for the vertical movement. So AB is 6 minus negative 1. So terminal, because it is AB, so x coordinate of B minus x coordinate of A. So 6 minus quantity negative 1 is positive 7, while BA is A negative 1 minus 6 is negative 7. Then we have B 3 comma negative 4, 3 comma negative 6. So this is A 3 comma negative 4, B 3 comma negative 6. AB is in the downward direction, so expect negative. It is B coordinate negative 6 minus quantity negative 4, so it's negative 2 AB. Then B to A, it's the upward direction, so it is positive. So y coordinate of A, negative 4 minus y coordinate of B, which is negative 6. So that's why it's positive 2. Then C, negative 4 comma negative 5, which is here. And B, negative 4 comma 6 up there. So AB is positive, upward direction. So it is the y coordinate of B, terminal, minus quantity negative 5, so 11, positive 11, while BA, directed distance BA is negative because it is in the downward direction, so it is negative 5 minus 6, so negative 11. Then Lastly, we have given the points AB, find the slope and the angle of inclination of AB in standard form in degrees. So we have point A 5 comma 4 and B 7 comma 7. So let's also plot so that we can see them. That's problem 15. So A is 5 comma 4, which is this, and B 7 comma 7. So that direction is rightward and upward. So the distances would be all positive. So this is 2 because x coordinate of B 7 minus x coordinate of A 5. So 2. This is positive 3 because AB is y coordinate of B 7 minus y coordinate of A 4. So 7 minus 4 is 3. So from the figure, tangent theta A, that's positive 3 halves. And tangent of theta is 3 halves. So theta is inverse tangent of 3 halves. So you'll get 56.31 degrees. So the slope of part A is positive 3 halves. And this is the angle. Then B, A negative 1 comma negative 1 comma 2, which is negative 1 comma 2 here. And B is negative 4 comma positive 3, which is there. So that direction is up to the left. So that's why the horizontal distance AB is negative because we have negative 4 minus negative 1. Negative 4 minus quantity negative 1 is negative 4 plus 1, so negative 3. While positive AB because upward, so y coordinate of B3 minus y coordinate of A2, so 1. So we treat this as positive first. We know that it is in the second quadrant reckoned from the positive x-axis. So this is the angle theta B. But we can solve for alpha first. Tangent of alpha is 1 over, don't mind the sine 3. So because the calculator will give us an acute angle 18.45 or 18.40 degrees. Therefore, theta B, which is this, is 180 degrees minus alpha minus 18.43. So theta B is 161.57 degrees. Then C, we have A negative 6 comma negative 3, which is this point, and B is negative 4 comma negative 2, which is that point. So that is in that direction. So theta C is positive, and because that's rightward and upward, both these components of distances of this line segment would be positive. So for x, for this horizontal distance, negative 4 minus negative 6 is positive 2 because it is AB, so B is the terminal point. Then this vertical distance is y coordinate of B, negative 2 minus y coordinate of A, negative 3, negative 2 minus quantity negative 3, negative 2 plus 3 is positive 1. So this angle, the slope is 1 half, positive 1 half for C. And inverse tangent of 1 half is 26.57 degrees. We now proceed to D, A negative 2 comma negative 1, which is that point. B is negative 5 comma negative 5, which is that point. This is the positive x direction, so it is this angle here in standard position. But the direction is down to the left, so both these distances will be treated negative. So for horizontal, x coordinate will be negative 5 minus quantity negative 2, negative 5 minus negative 2 is negative 5 plus 2, so negative 3. Then it is AB, so negative 5, we have negative 5 here minus negative y coordinate, negative 5 minus negative 1 is negative 4. So we treat this as positive so that we solve this alpha first. Arctan inverse tangent of 3 over 4 is 36.87 degrees. So imagine this is the x-axis positive to there. If you extend to this vertical line, that's 270. Therefore, this angle in standard position is 270 degrees minus 36.87 degrees. So that's why you get 233.13 degrees. So don't be surprised, it is automatic written there. It's explained here. Then finally at E we have 1 comma negative 3 and 4 comma negative 5. So that's 1 comma negative 3 and this is 4 comma negative 5. That direction is down to the right. So the horizontal distance is positive, the vertical is negative. So AB, x coordinate of B 4 minus 1 is positive 3. Y coordinate of B negative 5 minus negative 3 is negative 5 plus 3, so negative 2. So from the positive x-axis, this is the angle, but we can solve for this angle first, treating everything as positive. So inverse tangent of 2/3 is 33.69 degrees. Therefore, that angle in standard position theta E is 360 degrees minus 33.69 degrees, 323.31 degrees. However, the slope of AB is negative 2 over 3. So consider the sign back. So of course, it lies in the fourth quadrant where the slope is negative. So that's it for this video. I'm not uh, explaining it further because it's just slope, and for you as engineering students, you should be good in determining the slopes, angle they make, angle the line segments make with the positive x-axis, and also the calculators allowed. And remember the technique.